Section 1.3, Complex Numbers, Quadratic Equations in the Complex Number System. So we'll start off with complex numbers. So the imaginary unit I is defined as the square root of -1. Another way of saying this is that I squared is equal to -1. So if we start with the square root of -9, before we used to say that's not possible. And what we mean is it's not possible in the real number system. But if we allow for the square root of -1 to equal I, we come up with the answer 3 times I. Same thing with 4 times the square root of -25. That would be 4 times 5I, or 20I. So a complex number is a number of the form a plus bi. A is the real part, and b is called the imaginary part of the complex number. If b is equal to 0, then a plus b is a real number, because this guy wouldn't be here anymore, so you just have what looks like a real number. If a is equal to 0, but b is not, then you have a purely imaginary number, such as 3i or 20i, like we just saw. Example 1, perform the indicated operation and simplify. Okay, so we have the complex number 2 plus 3i, and we want to subtract 4 minus 7i. So just like when we had binomials, we would take this negative and we need to distribute it to both terms. So we end up with 2 plus 3i minus 4, and then plus 7i. Add the real parts together, so 2 minus 4 is a -2. Add the imaginary parts together, 3i plus 7i is 10i. And that's it. Part B, we have 8 minus 3i times 4i. So the 4i is distributed to both terms. We end up with 32i minus 12i squared. So if instead of an I we had an x, we would be done at this point, right? But we don't have the variable x, we have the number I. So remember, I is equal to the square root of -1, which is equivalent to I squared equaling -1. So we want to use this information right here to substitute a -1 in for our I squared. So 32i stays as it is, minus 12, and then this I squared is going to be replaced with a -1. This was 12 multiplied by I squared, so now we have 12 multiplied by -1. So 32i minus a -12, which is of course plus 12. So 32i plus 12. If you're asked to write the answer in standard form, the 12 should come first. So standard form is a plus bi. So the real part, the 12, comes first, and then plus 32i comes second. Okay, part C, this time we want to FOIL. So I'm going to start with the -1 and multiply that by both terms in the second binomial. So -1 times 4 is -4, and then I'll have minus 2i. And now I move on to the 2i, and I'm going to distribute that to both. So I have plus 8i plus 4i squared. Okay, so the -4 is fine. In the middle here, I can add my -2i and the 8i together, so I have positive 6i. And then at the end, plus 4. If you remember, I squared is equivalent to -1. So we really have a minus 4 here at the end. Add the real parts together. So 4 plus -4 is -8. And then we still have the plus 6i. So again, this answer is in standard form. So that looks like a plus bi. After you multiply like we did in parts B and C, if you come up with an I squared term, you need to replace I squared with -1 and continue. Example 2, we want to simplify this expression. Okay, so we have the opposite of the square root of -4. So if we just look at the square root of -4, since the square root of 4 is 2, this is going to equal 2i. So that minus, it just stays in front of it. So when we simplify the opposite of the square root of -4, we end up with -2i. And then I have -4 multiplied by the square root of -25. So the square root of 25 is 5. And again, because of that negative under the radical, the square root of -1 is I. So here I have 4 times 5i. Okay, so let's leave the -2i alone for now. We can multiply our numbers together. So 4 times 5 is 20. So I have -20i. Think of these as like terms, right? They both have the imaginary I with it, so we can add these together. Final answer is -22i. And finally, example 3, we want to simplify. So these expressions are not simplified because there's an I in the denominator. So we did something similar to this when we were simplifying and we had a radical in the denominator. So for this first guy, I'm going to multiply by I over I. So I'm multiplying my fraction by the number 1, so I'm not changing the value of anything. I'm going to start with the denominator. So 2i times I is 2i squared, and we know I squared is -1. So I have 2 times -1, which is -2. So this fixed the denominator, so now the denominator is just the number -2. There is no more I involved. In the numerator, we're going to distribute the I, so I have -5i plus 3i squared. So -5i. Remember, I squared is a -1, so I'm going to replace that. So we have -5i minus 3. There's a lot of negatives here, so I'm going to factor a negative out of the numerator. So that gives me 5i plus 3, because then I still have that negative in the denominator. And now it's like we're canceling those negatives. Again, before you can cancel, you have to factor something out. So I factored the negative out of the numerator and then canceled it with the denominator. I don't mind this as your final answer. If you're asked to write it in standard form, that needs to look like a plus bi. So first of all, we could think this as 5i over 2. The other fraction would be 3 over 2. So remember, both terms in the numerator get divided by 2. And then the 3/2 comes first. So final answer would be 3/2 plus 5/2 I. Okay, part B, this one's a little bit different because we have 2 terms in the denominator. So just like we did with radicals, when you have 2 terms in the denominator, we have to multiply by the conjugate. So since this is a 4 plus 3i, we're going to multiply by 4 minus 3i, top and bottom. And then we FOIL. So I'm going to FOIL off here kind of on the side, and I'm going to start with the denominator again. So I have 4 minus 3i, sorry, 4 plus 3i, and I'm multiplying that by 4 minus 3i. So 4 times 4 is 16. Then I would have minus 12i. Distribute the 3i, we get plus 12i, and then minus 9i squared. So we're doing this because the minus 12i plus 12i is going to cancel. So we have 16 minus 9, but remember 9 is being multiplied by I squared, so it's being multiplied by a -1. So this is really 16 plus 9, or 25. Okay, so again, once we multiplied, the bottom, the denominator, turned out to be the nice number, real number, 25. Okay, in the numerator, let's FOIL that as well. So we have 2 minus 3i times 4 minus 3i. We'll get 8 minus 6i minus 12i plus 9i squared. It's plus this time because we have a -3 times another -3. So that's going to be 8 minus 18i. So we replace this I squared with a -1. So instead of plus 9, it's really minus 9. 8 minus 9 is negative 1. I'm going to write that first. And I solve that minus 18i. So negative 1 minus 18i. Again, I'm okay with this as your final answer. Technically, if we're writing it in standard form, a plus bi, we would write it as two separate fractions. So we have negative 1 over 25 and then minus 18 over 25i. Okay, good. That's it for section 1.3.